Alright, good day students, how are you doing? This is me again, Sir Navarro, and welcome to our YouTube tutorial video. So in this video, we're going to discuss about the next type of variation, which is a joint variation. So here, we're going to target translate and describe relationship in which a quantity varies jointly as two other quantities or more. Okay, more. To a mathematical equation and then solve situations or problems involving joint variations. So let's before we proceed to the proper discussion, let's have this activity first. So complete the table by finding the length, width, and the area of the rectangle. So now here are the six rectangles. So let's fill in the following blocks. The rectangle A is given as an example. So let's fill in first the length column, then the width, and then the area. So let's have the length. Length for A is 1, 2, 3. There are 3 units, and then 1 unit iyang width. And then the area, of course, is 3 square units. So now let's go with the lengths of each B, C, D, E, and F. So the length is 1, 2, 3, 4, 5, and 6. So 6. And then this one is 1, 2, 3, up to 9. This one is, length is still 6. This one is also 6. This one is also 6. What about the width? The width of this one is 1 unit. And the width, meaning to say, this one, the unit. This one is also 1. This one is 1 unit, sorry. 1 unit. And then for letter D, rectangle D is 2 units, and then E is 3. F is 4. And then for the area, just have to multiply them together. So this is 6 square units, 9, and then 12, and then 18, and then 24. Right? Okay, so what's with this table values of this example? So if you notice, as the length increases, what have you noticed with the length? As the length increases and the width remains constant, what happens to the area? So the length increases. For example, here in letter D, E, and F, length increases, 3, 6, 9, and then the width stabilize. What happens to the area? Of course, it also increases. So when the length is doubled and the width is the same, the area is doubled. And with the increase as the width increases and the length remains constant, if you notice D and E and F, the length is constant, 6. The width increases. What do you notice with the area? Also, it increases. So the area of the rectangle is proportional to the length, the product of its dimension, which are the length and the width. When a variable y is proportional to the product of 2 or more other variables, then y varies jointly with these quantities. It can be 2 or more. So here comes the concept of joint variation, where x and y and z denote 3 quantities or more. Okay, it could be more than 3 quantities. Y, and the statement goes, y varies jointly as x and z if there is some positive k such that y is equal to kxz. So where k again is the constant of variation. So similarly, in the direct variation, they may look like same, no? So if you notice, there is just an additional variable. No? The same process when solving direct variation will be applied in solving joint variation. So again, direct variation and joint variation are just similar. It's just joint variation is an upgraded version of the direct variation. But yeah, I think most part of it is similar lang yun. Now let's proceed to solving. No? Let's proceed. By the way, the phrases that are going to be used, for example, y varies directly as x, it can be also used in joint variation. Let's say, for example, y varies directly as x and z. So if you notice, there are 2 variables mentioned already after y. So in direct, only 1. But in joint, can be more than 2. So in this case, for example, y varies jointly as x and z. So I can also say this in direct variation manner, y varies directly as x and z. Alright? Okay. Hope that's clear. Let's proceed to examples. So first example is, let's find k. No? So find the equation of the variation where a varies jointly as b and c, and a is 36 when b is 3 and c is 4. So let's find k now. So to find k, we must also first translate the variation statement into a mathematical statement. So a varies jointly as b and c, therefore a is equal to k, b, c. Again, where k is constant. So to solve for k, we need to substitute these values, three values, 36 for a, 3 for b, 4 for c. And here comes, replace lang the values. So a for 36, b is 3, and then 4 is c. So just multiply this two. This is equal to 12, right? So 12k. So to solve for k, we need to divide both sides, in order for the coefficient of k to become 1. So what should be divided? Alright, so it's 12. So we need to divide 12 on both sides, giving us the value of k, which is, what will be 36 divided by 12? Okay, 36 is 36 divided by 12, it's just equal to 3. Therefore, the constant of variation is equal to 3, or k is equal to 3, and this gives us the equation of the variation, a is equal to 3bc. Is that clear? Alright, so the equation of the variation will be a is equal to 3bc. Now let's proceed to solving another set of values. Let's proceed to example number 2. Yeah, it's clear naman. So if in example number 2, if z varies jointly as x and y, and z is 60 when x is 5 and y is 6, find z when x is equal to 7 and y is 6. Now let's proceed to the first step. Translate the variation statement to mathematical statement. So z varies jointly as x, so therefore x and y, so z is equal to k kxy. Alright, z is equal to kxy. Now, since z is equal to kxy, we need to find k first, and then substitute the first set of values. Again, first set of values. So z is equal to 60, 5 for x, 6 for y. And then this is 5 times 6, this is 30k. So what should be divided on both sides in order for the coefficient of k to become 1? Alright, it should be 30. So we divide both sides by 30, and that gives us the constant of variation as 2. Alright, because 60 divided by 30 is 2. Therefore, our equation is z is equal to 2xy. Again, our equation of the variation is z is equal to 2xy. Now, let's proceed to finding z. Our z is just, we just have to substitute 7 for x and then y for 6 for y in this equation na. Not the first one, but the one with the constant of variation. So if z is equal to 2xy, so we substitute na 2 times 7 times 6, which is equal to 84. 2 times 7 is 14, times 6 is 84. Which is, of course, z is equal to 84. Okay? Is that clear? Can we proceed now? Okay. Let's go. Example number 3. This will be the last example. Example number 3. If v varies jointly as w and u. By the way, just when there are more than 2 variables involved in the problem, please follow the order when it was stated. For example, WU, diba? Which one goes first? Is it U or W? URSTUVW. See, U goes first before, but alphabetically. But yeah, since the sequence is, since the order here is VWU, which translates the equation to What should be the translation? Okay, so it's V is equal to KWU. Okay, just follow that one. Although it won't matter, no, but yeah, let's just follow the sequence here. So to solve for K again, we need to substitute the first set of values, which is V is equal to 28, 8 for W, 7 for U. So there, let's substitute now. V 28, W 8, U is 7. Then 8 times 7 is, how much is that? That's 56. So if that's 56, so 28 equal to 56K. Then to solve for K, we need to divide both sides by how much? In order for the coefficient to become 1, it should be divided by 56. So if divide both sides by 56, and since the left side is the numerator is smaller than the denominator, so we need to reduce lang if it's reducible. If it's not, then leave it as it is. But this one is just equal to 1/2. So our equation will be V is equal to 1/2 WU. So V is equal to 1/2 WU. Now to find U, we're going to use this equation to find U and then just substitute the second set of values. So V is 63 and then W is 14. So 63 equal to 1/2 14U. So 1/2 times 14, that's just 14 divided by 2. Am I right? Similar to 14 divided by 2, which is equal to 7U. 63 equal to 7U. And then in order for us to solve for U, we have to divide both sides by whatever the coefficient here, which is 7. So, which gives us the U value, which is 9. Therefore, our U is 9. Okay? So, for more examples, you can just comment down below. I'll just send it to you. Thank you and God bless.